So we shall study today about the core. In the last video we have shown the forces acting on the staining. Here we shall discuss the forces on the cores. The core, as we have discussed, is the cutting edge and portion of the staining which is attached to the core. Carb transfers all the superimposed loads to the soil through the cutting edge while sinking. The material used for cores may be timber or RCC. The forces acting on well cores are shown in this figure. Total horizontal force on the well core on the both sides is also shown. Now here D0 is the external diameter, that is from the center of the total end to end diameter. Di is the internal diameter, and forces are the weight from above the staining, and the horizontal forces, and the total reaction is R, and the angle between horizontal force and the R, horizontal direction, and R is theta. Then the bottom plug is created, and it is cured. After curing, filled with sand. The well will be filled with sand in the saturated condition. It provides stability to the bottom of the well, eliminate the tensile force at the top plug. As you see, this is the portion just after filling the sand. The plug will be constructed, and above which the well cap is constructed, which is reinforced concrete. Well cap is reinforced concrete, but top plug is plain concrete, plain cement concrete, or it may be lean concrete with little reinforcement if well cap is not provided. The thickness of the top plug is generally kept greater than the 50% of the smaller dimension of the dredge hole. Well cap is constructed as a slab. Resting on the well, it is used to transfer the load of pier to the well. As the shape of the well pier and cap are different, the well cap forms an interim layer to accommodate the pier. The well cap is so designed that the base of the pier is provided with a minimum all-around offset. The center of the well cap is made to coincide with that of the pier and not with that of the well. Such positioning nullifies the effect of the minor shifts which might have occurred during well sinking. Components of well. We have got different components of the well. With the well foundation, this is the cutting edge and the staining. Then come the bottom plug, sand filling and bottom plug. Then comes this top plug. Then comes the well cap. Then comes the pier. These are the components in sequence. So this is your well foundations is below this level bottom slab. You can see above which the pier is constructed, and above which above the pier this bridge is resting on a shield. You can see here is also construction process. Forces acting on the well foundation. What are all the forces on the well foundation? First is dead loads. It includes the weight of superstructure, pier and abutment, plus self-weight of the well. Live loads. What are the live loads? The load caused due to tractive effect of the vehicles, or the vehicle load also, and human beings, furniture of the floor and other materials which are kept on the bridge also. They are coming as live loads. For road bridges, the live loads may be specified by standard specifications and code of the practice of road bridges. Impact load. The impact load is the result of live load and shall be considered only during design of the pier cap and the bridge seat on the abutment. We have seen the seat on which the pier was in the previous figure. So in the bridge seat designing and designing of the pier cap, these impact loads are taken into account. In other components are in the other components, this impact load is neglected. Wind load is seen only on the exposed area in the elevation and hence act laterally on the bridge. If you take the x direction as the moving direction of the vehicles on the bridge and y direction is the lateral direction, so wind will act on the y directions. According to code, IS code 875, provision of the wind on superstructures of structures live load situated above the water levels are calculated. Then water pressure, if it due to water current, you have seen the pressures on the hydrostatic pressures on the staining, but here this is the pressure, that is current pressure due to waves. So this is this acts on the substructures lies between water level and the maximum scour level. In case of piers lying parallel to the direction of water, intensity of water pressure shall be determined by P equal to kV square. P is the intensity of pressure in kilonewton per meter square. K is the constant. Maximum value is 0.788 per square 100 piers. Minimum value is 0.237. The calm water is expected, and B is the velocity of the current, the water flow in meter per second. This velocity is taken as surface velocity, which is under root average velocity, under root into average velocity. Average velocity is calculated in the as per in hydraulics, in the average velocity, the section of the river where this average velocity can be calculated. Longitudinal forces, these are the due to tractive and braking forces. Longitudinal forces depend on type of vehicles and bearings. These forces get transferred into the substructure via fixed bearing and friction in movable bearings. Earth pressure, Duncan's theory of columns is utilized to calculate earth pressure, that is the portion of the pier, portion of the well which is below the soil. Then come the seismic forces, which acts on every member, superstructures. In the case of earthquake, this is alpha into weight. Weight is the W is the weight of component, alpha into W, so W is the weight of component on which the seismic force is required. Alpha is seismic coefficient depending upon the type of seismic zone, and it value is taken from 0.01 to 0.08.